Hello guys, in the previous video we managed to solve the Advent of Code Day 7 part 1, and in this video let's continue the part 2. And without further ado, let's start. So let's continue the part 2. So just to recap, in the previous video, part 1, we needed to calculate all the passing test values. So between every kind of this list of numbers we had. So we had list of numbers, and between every number we needed to add some operator and then calculate it. Could we manage to get the test value? So we managed to get that done. So in this part 2, the engineer seems concerned the total calibration results you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants are holding third type of operator. The concatenation operand combines the digits from its left and right inputs into single number. For example, 12 and concentration operand 345 would become 12,345. All operators are still evaluated left to right. Now, apart from the three equations that could be made true using only addition and multiplication, the above example has 3 more equations that can be made true by inserting operations. Okay, adding up all 6 test values, the 3 that could be made before using only plus and multiply, plus the new 3 that can now be made by also using that, propose that new total calibration results of 11,387. Okay, so let's add day 7 part 2, and for this I think we can, or we should start by continuing with our input test set. Now we have the input rows, yes, and then to calculate the combinations. That is something that we want to change a bit. I guess we can just extend this by that, and just for kind of keeping it easier, let's have just one pipe operand, so that we don't need to get as many values or like modify the rest of the logic too much. And now if we run the code for the first input row, we should, or maybe let's take the second, since it had 3 values in the list, we should get some results. So let's print the item. So we got this, we have quite much of them, but let's see that the duplicated ones are not problematic, but these other ones. So yeah, we start to have that as well. I guess we will now have 3 duplicates of every case. Doesn't matter. Yes, that looks good. So we now rerun this section so that we reset all the, then we can just run this. It executed fast, and then we want to extend this calculate value method also a bit, and elif operation is the pipe one. We will return integer, that is string current value, and then another string of number. And just to make sure that this is behaving as we want, we will have a as 1, 2, 3, then we have a b that is 4, 5, 6, and then we have this b we have exactly. And then we can delete that one and run this. It should work as expected. And then we just need to run this value or this block of code. And if we run it, we should have items in past test values. Now we have 6. And if we sum this up, can we get the correct number? 11,387. Looks good. So next we will this block of code again. That went well. Yes, we have all the items existing there. And now we want to run again this, and it will take some time. So now it will generate 3 times as much those combinations, but I think it should be fine. This is a bit like brute force technique, but let's see. Maybe should have had the index print here as well this time. I can actually see that our RAM usage is peaking, so yeah, I think we can handle it here. Let's see. Processing crash after using all available RAM. Okay, I think we could then. How could we do it a bit better? At least what we could do is enumerate this so that we have the index available, and then item number, and it clearly can't free up the memory after utilization, or I think that there is some kind of leak happening that it can't. So let's do so that we will split this up a bit. And so how many rows we had? Row we had. Yeah, we need to start from the beginning, I guess. This, then we need to, then this. Okay, 850. So what happens if we just limit it to be 400 or maybe 100 and then run? I'm wondering that can we kind of achieve some memory efficiency if we just run it in batches, so that if there is some issue with the memory or freeing up the memory. Now we have the start from the 100 and let's continue to let's go see, can we get this? Okay, now it's stabilized a bit, and let's see, can we just do another 100. Okay, it's spiking up. But it managed to free up the memory somewhat, or a bit. Okay, and then if we run a bigger batch, it will rocket. So most likely I need to do so that I'll get the values out here, and then we can. So now we have the all 400 items. So first 400 we have calculated their combinations. So if we now run this and then this, yes, now we have the first batch of 400 items checked, and the current number is this. Let's actually store it in separate cell. And what we want to now do is restart this environment, runtime, restart session. Yes. What we want to do is that the memory utilization will go down, and we can run the rest of the code or rest of the calculations. So first run the inputs, then we will calculate this or generate the data classes as we did last time. Then we will run the add operand function so that it's available. Then we check the input rows, length 850, and now we can just say 850. We should have enough RAM to handle that amount of items. It will go relatively close, but we should have them there. Yes, we have all the combinations generated, and now we just run the calculations. Yes, and now we have the result. This was the previous number, and then we get the new number, and this is the result. Let's try to submit it then. Yes. Yeah, we managed to get the day 7 done now completely, and this was clearly more kind of calculation heavy day, but in the end very interesting. Thank you for watching, and if you liked the video, please like and subscribe the channel, and see you guys in the next video. See ya.